Power.
Force.
All right.
So these three terms, work, power, and force, are hugely important in terms of physics and chemistry and a whole bunch of other areas of science. So as we kind of go through this, we're going to discuss briefly each part. So the first one is work. So work is abbreviated as a W, conveniently enough, and it's measured in something called joules. Now, joules is a common unit that's used for a lot of things, energy and work, and all sorts of different places.
It's a metric unit.
So what actually is work?
I bet it's force acting over distance is my guess.
You'd
off the top of
probably
my
be
head.
right.
Wait. Yes.
Yes.
Yeah, that
Very
looks
good.
right.
So work, you got a force, which is just something pushing, basically, or pulling, and it's over a certain distance. So the idea is that you have to cause it to move. If you don't move, there's no work. So I can push as much as I want against Mr. Harkins, but if he
But
doesn't
super
actually
tough.
move,
No work,
no work is
done.
being done.
Yeah.
So you're telling me when I got my car stuck in a ditch this weekend, and we were trying to push it out and it didn't move, we actually didn't do any work?
Well, you didn't do any work on the car. You might have been doing work on your arms and your muscles, but not on the car itself.
And the
Okay.
tires are rotating,
Right.
spinning around and that, so...
Yep. So work has to be in the same direction as the force. So if you're pushing, it's
Okay.
got to move that way. If you're pulling, it's got to move this way. And there's a pretty simple calculation for it. To calculate work, you just simply take the amount of force you have times the distance.
Okay, so
Plain
to
and
do
simple.
work, you've got to have something move.
Exactly.
So you could hold like a 50-ton weight over your head and not move at all. You're not doing any work.
True.
Just want to make sure.
Got it.
Okay, cool.
Yep. And big thing there, it takes energy to do work.
So
You might want to write that down on there. Not a spot.
energy is required to get
Without
anything
energy,
working.
there is no work.
Yeah, they should write that down.
I
think
would
so.
definitely say that. How about this one? Power. Power is abbreviated with the letter P, capital P, and the units are either joules per second, so we have a time component in there, or it's in watts. So a joule per second. Watt? Isn't that nice?
Mm-hmm.
So it's watts. It's named
Watt,
after
did
the
you say?
scientist. Watt. Anyhow, bad joke. Power is the rate at which work is done. So you can see joules per second. Rate just means there's time in there. So power is basically how quick or how slow you do work. The faster the rate, the more power you generate. So if you take a look, the shorter the time component, the more the power is up. And you can see that in our equations there. Either power is equal to work divided by time. So if you have a small time on the bottom, you're going to have a bigger number for power. Or power is equal to force times distance, because remember, again, work is equal to force times distance. So we just substituted force times distance.
So we just took the other formula and put it in there?
Yeah, just stuck that in there,
You
because
can do
work
that?
equals force times distance. Yeah, as long as they're
Man,
equal.
Math is crazy.
And again,
Yeah.
still divided by time.
Crazy how
so
it works perfectly every time.
Yep, exactly. You almost think it's how things run. But to give you guys a couple examples, like a car's motor accelerating or a sprinter running, they're exerting power, they're using power, and those have two components in where they're doing work, and they have a time component in that.
Which one probably has more power, the car or the sprinter?
Definitely the car, faster acceleration. It's going to cover
True.
greater distance in a shorter amount of time.
What about
Also
Usain?
more weight,
What about
so it's more
Usain
force.
Bolt? He's pretty fast.
He is
Yeah,
fast.
so compared to me, if me and Usain Bolt run the same distance, but he runs it like way faster, that means he has more power, right? 'Cause he's
more
doing it
power
over
because it's
Gotcha.
going to be
shorter
less
period of
time to cover the same distance.
Got it.
Yeah.
Cool.
Give you guys a couple of
But we
things.
would do the same amount of work, right?
Yes.
You can do
Yes.
the same amount of work and have different power?
Yes,
Okay.
absolutely. You can do the same amount of work. To give you guys one real big thing, you can see a couple of notes down at the bottom. The big one that I want you guys to take a look at is 1 horsepower equals 750 watts. Definitely write that down. We're going to use that in class for practice. So how about the next one?
On it.
All right, so our final topic to discuss here.
Force.
is force.
Ooh, force.
Now, force is abbreviated with an F, and the units for force are named after a very famous scientist, Sir Fig Newton.
Sir Fig Newton made
excuse me.
delicious cookies.
Sir Isaac Newton.
No. Fruit
Yeah.
and cake.
Fruit cake, thank you. Thank
Sir
you.
Isaac Newton, actually.
Apple on the head.
Oh,
Yeah.
okay, okay.
Was that really happened, though? I don't think
I
that-
think it
Probably.
actually. I don't know.
I don't
That
know.
might
It's a
not
nice
have.
story,
It's
but
a
I'm
good
sure he
allegory.
observed lots of things falling to the earth
Yeah.
and said, gravity.
No.
Yeah.
Gotta be
I'm
a
sure he
force.
was the only person who ever once saw something fall to the ground
Yes.
in all the years of life.
So anyway, a force, and the reason we mentioned gravity is gravity is actually an example of
Yeah, exactly.
force.
Of
But
acceleration.
acceleration.
Yeah, of acceleration. But anyway, force is a push or pull on an object in any direction.
So
Okay.
just think of it literally like that,
Oh.
or like I pull like with my amazing force powers.
Creepy.
Yeah. So anyway, the formula for force is mass times acceleration. F equals ma. You're going to use that formula
A lot.
A lot. So
F
remember
equals
that.
Write it down
MA.
and
Write
remember
it down
it.
just so you got it.
You could also calculate the force of an object like on the ground. Because actually, when we measure weight, like when we say we're such and such pounds,
Yeah.
we're actually measuring the force
The
that we
force,
put on the ground,
yeah.
not our mass.
Right.
We can actually do it in newtons as well. Yeah, we can figure it
So
out in newtons.
force could also be mass times gravity because gravity itself is an acceleration.
Yeah, 9.8 meters per second
yep.
squared.
Yep.
That's the
Yeah, anything you-
acceleration due to gravity
Anything you drop
On
that doesn't have
Earth.
air resistance will accelerate at 9.8
Yeah.
meters per second to the ground.
on Earth.
Like if I drop this mouse, which I'm not going to do right now because I don't want to buy a new one.
No.
But anyway,
Word.
Yep.
so yeah, anything else to add about force?
I
no,
think we're good.
other
Let's
than
move on.
gravity's different on different planets.
Oh yeah.
Yeah, we'll talk about that.
Yeah.
So just real quick summary of stuff.
Wrap it all up.
Work is measured in joules or Newton meters, which is just kind of a weird thing, but it's the force times the distance.
Yep.
So Newton from force, meter from distance.
Distance is meters. That's our metric unit for distance. We know that one.
We measure force in newtons.
Yep. Power joules per second or the watt.
And then time is seconds, and we know time is seconds. 'cause
And you
we
might
work
be
with that a
excited.
lot.
You might be excited to find that we're going to be calculating a lot of work problems here or power problems here, and you could actually use a little triangle for that one.
Yeah.
Like the
Like
density
the
triangle.
triangle.
Ooh,
Yeah, this is a
talk
good
more
one to
about
have
that.
down too. Put that on your notes for
Definitely
sure,
copy
guys.
that down. We'll be using that
Yeah,
in
we're
class.
going to be going all over that. W divided by P equals T and stuff like that. So
All right.
do your
All right.
checkpoint, guys. Kick butt on it. Remember, you can do it multiple times. Egon Spengler, rest in peace.